You know, there's a super material hiding all around you, in places you probably see every single day. It's incredibly tough, it's vibrant, and believe it or not, it's been around for thousands of years. So today, we're going to pull back the curtain on vitreous enamel, the unsung hero of our modern world.
Okay, picture this. You're standing in a busy subway station. You've got crowds of people, the air is thick with dust, and the walls are getting bumped and scraped by countless bags and shoulders day in and day out. And yet, somehow, they still look clean, almost new. What's the secret?
And then you've got graffiti, right? It's a constant battle in pretty much any public space. But these particular surfaces, well, they seem to just shrug off paint and markers like it's absolutely nothing.
Or what about a city tunnel? I mean, think about it. It's constantly being bombarded with corrosive exhaust fumes, dampness, the constant rumble of traffic. What kind of material could possibly survive that relentless assault and still look good?
Well, the answer to all of these questions is one single remarkable material, a true unsung hero that's been hiding in plain sight this whole time. That material is vitreous enamel, which you might also hear called porcelain enamel. It's the secret weapon behind the durability and just sheer longevity of some of our most demanding public spaces.
So what exactly is this stuff? It sounds kind of complex, but the core idea is brilliantly simple. It combines the best properties of a few different materials into one absolute powerhouse of a composite.
Okay, so the concept is just brilliant in its simplicity. You take a layer of glass and ceramic, you bond it to a super strong metal base, usually steel, and then you fire it in a furnace that's hotter than a volcano. We're talking over 800 degrees Celsius. See, it's not just a coating. That incredible heat literally fuses the materials together into a single new substance with unbelievable strength.
And get this, while we see it in our subways today, this is not new technology, not even close. Enamel's journey actually began 3,500 years ago in ancient Egypt. Artisans used it to create this vibrant, timeless jewelry. So the same basic principle that protected a pharaoh's treasure is now protecting our city tunnels. How cool is that?
So how do we get from raw steel and some minerals to these indestructible panels? Well, the process is this amazing blend of high-tech precision and just pure elemental force. It really is a material that's forged in fire.
It all starts with a precisely shaped steel panel. But before any coating goes on, that surface has to be perfectly chemically cleaned and prepared. This step is absolutely critical to make sure there's a permanent bond. Then, an auto-spray coating system applies these perfectly even layers of enamel. And finally, the magic happens in the furnace. At over 800 degrees, the glass doesn't just dry on the steel. It melts and fuses into it, creating one incredibly tough, unified surface.
All that work in the factory leads to some really incredible benefits. This is the why. This is the reason architects and engineers turn to vitreous enamel when a project absolutely positively has to last.
I mean, this chart really says it all. While the regular paint might start to fade after just a few years, vitreous enamel keeps its color for over 3 decades. And just look across the board. Anti-graffiti, scratch resistance, fire resistance. Other materials might do one of these things well, but almost nothing checks every single one of these boxes. It's truly in a class of its own.
To put it simply, these are its superpowers. It's incredibly durable, it's impossible to graffiti, the colors will never fade, it won't burn, and it resists pretty much everything from harsh weather to acid. And maybe the best part, especially if you're a city manager, it's virtually maintenance-free.
Okay, so we've covered the science and the specs. Now let's go find out where the super material actually shows up in our world. And I guarantee you've walked right past it 100 times and never even knew what you were looking at.
The most common place you're going to spot vitreous enamel is in a metro or a subway station. It's just the perfect material for a high-traffic, high-wear environment that needs to look good and stay safe for decades to come.
And hey, this isn't some local secret. Just look at the major transit hubs all across Asia and Australia, Singapore, Hong Kong, Taipei, Perth. The world's busiest cities are relying on vitreous enamel to keep their public spaces safe, clean, and looking sharp for the long haul.
Now, let's go even deeper underground. In the grueling environment of a road tunnel, vitreous enamel is a total lifesaver. Its bright, reflective surface bounces light around, which makes the whole space safer for drivers. And all that soot and grime from the exhaust, it just wipes right off.
And just to give you a sense of the scale we're talking about, the central Wan Chai bypass tunnel in Hong Kong alone used 76,000 square meters of these panels.
That is a massive amount of material covering the walls of a critical piece of city infrastructure.
But it's not just about being tough. Because the color is fused right into the material itself, it will literally never fade. This makes it the perfect canvas for these huge public art installations that can turn a daily commute into an inspiring gallery experience.
You know, creating something this resilient isn't easy. As the source material points out, it demands deep expertise and just a relentless focus on quality. You're not just making a panel, you're engineering a piece of the future, something that's built to last for generations.
So here's a little challenge for you. The next time you're on your commute, look a little closer at the walls. Now that you know the secret, I bet you'll start spotting this hidden hero of engineering everywhere, just quietly making our world better.
And that really leaves us with a bigger question, doesn't it? We clearly have the technology to build things with incredible foresight and permanence. So if we can do it for our tunnels and our train stations, what else in our world should we be building to truly last?